Greetings. I'm just running through a problem that I presented to my Year 10 class recently, which is here's a straight line with 2 points on the line. Find a parabola that passes through these points on this line. Now, there are infinite number of solutions to this question, so that's a bit of a clue. And but not every solution is a solution. In other words, even though there are an infinite number of solutions, not all possible lines in the world will work either. So I hope that makes sense. We'll talk about infinities of infinities another day. So the way I'm going to approach this problem, there are many ways to approach it. I'm going to approach this using the generalized form, and the reason I choose this form is right now and Friday afternoon, I'm being lazy. I'll be honest. It's the one that I don't have to. It's easiest for me to remember. You can, however, start off by using the turning point form or the x-intercept form. And actually, as a matter of fact, I would challenge you to try and solve this problem using a different form to the one that I'm demonstrating here, because the procedure is still the same. And the procedure is the easiest way to solve. So I've got a function here. Think of it this way. I have a function of x, which is equal to y, which is equal to ax squared plus bx plus c. And I want to ensure that for specific values of x, in this case, we've got x is 2 or 6, I get specific responses for y, which is 3 or 7. In other words, I want to make sure that these variables here, a, b, and c, are set in a way that when 2 goes in here, 3 comes out, and when 6 goes in there, 7 comes out. So I want to force that to happen. And how I do that is my favorite tool. One of my favorite tools is substitution, probably the unsung hero of algebra, or at least reducing cognitive load. So let's substitute in the first value. So I'm going to sub in a, which is 2, 3, into the generalized form. So 3 is equal to ax squared plus bx plus c. And, oh, sorry, not a. Let's go a times my x is 2 squared plus b times 2 plus c. I can simplify that as 3 is equal to 4a plus 2b plus c. And I'm going to call that equation 1. I can't really, I can rearrange this, but I can't really simplify it. So I'm just going to leave it as is. Now I'm going to sub in point B, which is 6, 7. So that's going to be 7 equals a times 6 squared plus a equals 7 times 6 squared plus 6b plus c. And make sure my b looks more like a b. In other words, 7 is equal to 36a plus 6b plus c. Now I could simplify that. Like I could bring out a common factor here, but I don't need to right now. I'm just going to leave it like that. So this is equation 2. So I've got 2 equations and 3 unknown variables. It is impossible for me to solve this for A, B, and C. I actually need a third equation, and there's not enough information for me. In this problem, I do not have enough information to create a third equation. I've only got 2 points, so I can only create, I can create an equation from point A, I can create an equation from point B. I could try use one of these other forms, but they're just another form of the same equation. In other words, trying to put 2, 3 into this form, that is no different to putting 2, 3 into this form and rearranging the equation. So that's not going to work either. So what I need to do here, and actually just while I'm on that, I won't go into the details, see if you can work it out. But if I must make sure that I'm using the same form for both substitutions. I can't use one form for one substitution and another form for the other substitution, because this A, this B, and this C is not the same pronumeral as this A, H, K, or this A, B, C. It's quite terrible that I've got A, B, C here and A, B, C on the right. They're different A's, different B's, different C's. They're just a generalized form just to illustrate the shape of the equation. It's like the pattern, I should say, to demonstrate a pattern of the equation, not intended to be the same pronumeral. All right, I digress. So I've come to two equations. So what I want to do now is I would like to simplify this equation. And what I'm going to is, because I understand parabolas, I know that I can solve this with a parabola that does something like that, or I can solve it with a parabola that does something like that, or I can solve it with a parabola that does something like that, or so on and so forth. In other words, there's an infinite number of parabolas I can go through here. So what I want to do to make this easier for me, I want to solve to find a parabola, I want to simplify my generalized equation. I want to simplify it somehow. And the way I'm going to do that is I'm going to get rid of this variable c, this pronumeral c. How I'm going to do that is I'm going to go 1 minus 2. So I'm going to subtract the two equations. I'm using elimination now. So 3 minus 7 is minus 4 equals 4a minus 36a is minus 32a. 2b minus 6b is minus 4b, and c minus c is equal to 0. Okay, I got negatives all three, so I'm going to multiply both sides by minus 1. That gives me 4 is equal to 32a plus 4b. Well, that's as far as I can go. Plus 4b. That is as far as I can go. I can't do any more. I have no more information. But that's great, I have no more information. I can choose to set one of these pronumerals to any number I want. And as long as this equation holds true, so in other words, A and B are related in order, if I set, have I set C to 0 yet? No, I haven't set C to 0. I need to find a value for C. All right. Just because I eliminated it doesn't mean I didn't find a value for C. So I can't simplify that further. So let's rearrange this into, um, just bear with me while I think. Oh, 32A, 4B, no, that doesn't work. But 2B, see there's a 2B here? I'm going to make this 2 equals 16a plus 2b, and then 2b equals 2 minus 16a. I'm going to call that 3. Now, no, I'm just leaving it as 2b. Why? Because I can replace, if 2b is here, I can use substitution to replace this 2b. So 3 is getting substituted into 1. So that's 1 minus 2. Sorry, fixing that. So 3 equals 4a plus 2b plus c. I'm going to substitute in the 2b there. So that becomes 3 equals 4a plus 2 minus 16a plus c. Now let's simplify this a bit. I can go 1 is equal to minus 12a plus c, or c is equal to 1 plus 12a. Good. So I have an equation in terms of a and c. I have an equation in terms of a and b. So these are my key, let's do this. These are my key equations. Now, as mentioned before, you can't simplify, I can't find a value for a, b, or c because we don't have enough information. That's awesome. It means I get to choose values. I can choose any one of them, and this is where I'm going to be strategic. Y equals ax squared plus bx plus c. If I know I have 3 pronumerals, a, b, and c, I can choose any one of them to satisfy, and to be any number I want to satisfy this equation. Now I can't, because I want to make my life easy for myself, I'm going to set a, b, or c to 0. Now, if I set a to 0, that's not going to help me because I lose my x squared term and I end up with a straight line. So I need a parabola, so I cannot set a to 0. I can set b to 0 or c to 0, and have a think about what that will do. If I set c to 0, that's my y-intercept. That means I'm going to have a parabola that goes through. So let's try it. So let's try c equals 0. So then from equation 4, I can say 0 is equal to 1 plus 12a. And so a is equal to, it's late at night, minus 1/12. Okay, then go substitute a into the other key equation I had, which is 3. And that tells me 2b is equal to 2 minus 16 times minus 1/12 because I substitute in the a value. So I'm just going to get rid of that. 2 is equal to 1 minus plus 8 on 12, which is equal to 20 on 12. Hopefully I didn't make a mistake. Let's find out. So therefore, y equals a minus 1/12 x squared. Let me just clean that up, sorry. 1/12 x squared plus plus 20 on 12x plus 0 should satisfy the graph, for lack of a better word. Let's test it out. So let me pause this and I'll test it out. Hang on. Pause. Okay, I am back and I've plugged in. So while I was paused, I quickly worked out the gradient and the intercept. So there are many ways to work out the gradient intercept. I like the substitution method. It's a bit more rigorous, but really the shortcut is rise over run. So that's 4 over 4. So gradient is 1. And once I could see the gradient is 1, I knew a step back to intercept will be 1. So the straight line that goes through this graph, these 2 points, is here. Y equals, y equals x plus 1. And we can see that it goes through the point 2, 3, 2, 3, and 6, 7. So this is not the same one I did in class the other day. 6, 7, there you go. So it goes through those 2 points. And we find the equation I just created, y equals minus 12x squared plus 20 on 12x plus 0, excuse me. That is this parabola I've drawn here, and we can see it intercepts a line at those exact 2 points. So I'm just going to take a pause again. So I've verified my work by graphing and use technology to check that I was correct. So I know I'm correct. I want to just go through, I'm going to pause, and when I come back, I'm just going to explain how I knew to do that. Why did I choose to do that, find that approach? What information was important for me in solving that? Okay, a quick recap. I had a problem, find a parabola that passes through these 2 points, but I only have 2 points. I guess I know from experience I've learned in the past from simultaneous equations. Here, if I use a general form, if I use any form of a parabola, I have 3 unknowns. A, H, K for this form, or A, B, C for the other 2 forms. I have 3 unknowns. In order to solve this problem, I need 3 equations, but I can only construct 2 equations from A and B. So I need to find a strategy to give me a third equation. The good news here is I get to choose what my third piece of information is. So by substituting in these 2 points, A and B, I'm able to produce relationships between A, B, and C, and I can use those relationships to cancel out one of the variables. So I chose manually just to set C is equal to 0, and then I can determine values for A and B. I could have made C equals 1, I could have made C equals 5, I could have made A a particular value. So I could basically, these 2 points will help me solve A or B or C if I know one of them. Once I know one of them, then I can calculate the rest. So I can choose any value for A, B, or C, and then use these relationships that have been created from equation 1 or 2 to determine the others. Let me just show you what that looks like visually. So in other words, what I've just done here when I was paused, I was just playing with different representations of A, B, and C, and I notice here I've got B and C in terms of A. In other words, I can just have one variable. So by determining the value, by determining B and C in terms of A, I now have an equation ax squared. So I've simplified the equation to have only one unknown pronumeral, and that's A. I've got ax squared plus 1 minus 8ax plus 1 plus 12a. So my B term is here and my C term is here. And that came from working out which variable I want to isolate. Now you'll notice that with these relationships holding, I can choose any value for A, and every curve I'm creating goes through those two lines. If this is a complex task, some people will get what I'm doing. I know I'm not explaining it the best this time of night. Um, I strongly recommend having a play with it and seeing if you can develop an intuition for exactly what's going on here. All right, that's all I wanted to cover. If you've watched this, thank you. And I wish whoever's watching this all the best for their future and their mathematics studies.